Section 4.4 is evaluating logarithms and the change of base theorem. So we have something called the common logarithm, and it says for all positive numbers x, the log of x refers to the log base 10 of x. So the one thing I really want to mention here is that when we don't see the base, when there is no number written down here, the number is understood to be 10. So it says use the calculator to find the values of, and we have some problems here. So let me get my calculator, and I'm just going to move it over to the side. Turn it on. Let's clear all this business. Okay, we want to find the log of 1,000. So on my calculator, I'm going to hit, should be a log button right here, and I'm going to enter in the number 1,000. Okay, and then we're going to check our answer and see what it is. So we're coming up with 3. Okay. So before I go on, I know I can do this on my calculator, but I want to make sure I have an understanding of what's happening here. So again, remember the base is not written here, but it's understood that the base is 10. So what this problem is saying is 10 to what power would give me 1,000? Well, 10 to the third power would give me 1,000, okay? So same thing here. This is going to say 10 to what power is going to give me 142? Well, I know that 10 to the first is 10, and I know that 10 squared is 100, and we just figured out that 10 to the third, maybe we knew this already, was 1,000. So I know it's not going to be like an integer, it's not going to be a whole number, but it's going to be a number somewhere between, what, 2 and 3? Because 142 is between 100 and 1,000, and it should be closer to 2 because 142 is much closer to 100 than it is to 1,000. So let me take my calculator again. I'm going to hit the log button. I'm going to hit 142. And again, I should be coming up with a number relatively close to 2, a little bit over the 2. There it is, 2.15, right? So 2.15. Now, guys, I wrote 2.15, but if you notice, there was, 2288344. When you're doing this on my math lab, it'll ask you to round to a particular number. I'm putting 2 decimal places here, but if it tells you to round to 3, then, put 215, 2, whatever it happens to tell you, okay? Okay, so let's do this third one here. So let me take my calculator again. I'm going to type in log. Where's my log button? Right there. And I'm going to type in 0.005832. And let's hit enter. And I'm coming up with negative 2.23. Negative 2.23. Okay. So again, I'm just trying to get an idea of what it is I'm looking for here. All right. So, excuse me. So now it says the natural logarithm. It says for all positive numbers of x, ln of x, this is how I read it, ln, just because those are the letters that I have, is equal to the log base e of x. So if you remember in the previous section, we did that continuous interest problem, and our formula looked like this. We called it the PERT problem because it looks like the word PERT. So this is where that e is coming from, okay? So again, this is asking me what is the log or the natural logarithm of the base e to the power 3. So I'm going to take my calculator. First thing I'm going to do, I'm going to clear it out. There's an ln button right here to the left of the number 4, so I'm going to hit ln. Okay, and now it's asking me, what am I going to type in? I'm going to type in e to the third. Remember, the way I get to the e is I have to hit the second button and then my ln, so there's my e, to the third power. So I'm going to close those parentheses. If you notice I need to close the other set of parentheses, I'm going to hit enter, and my answer is just 3. Again, let's make sure we understand why is this the case. So remember, ln of e to the third is the same thing as the log base e of e to the third, right? So it's asking me here, e raised to what power would give me this? Well, e to the third power would give me that right there, okay? So the natural log of 142, I'm going to do the same thing. I'm going to hit ln 142. I'm going to close that off. I'm going to hit enter. And again, to 2 decimal places, I'm coming up with 4.96. Again, I'm just rounding to 2, but if it tells you to round to 3, then be sure to round to 3, okay? And now, one more. We're going to go ln of 0.005832. So notice, guys, these are straight calculator problems, right? And again, I'm coming up with a negative 5.14. Negative 5.14. All right, so let me keep scrolling down here. All right, so here we have the change of base theorem. Change of base theorem says for any positive real numbers x, a, and b, where a is not 1 and b is not 1, the following holds. Okay, so here's my change of base theorem. It says the log base a of x is going to be equal to the log base b of x, so we're going to introduce a new base divided by the log base b of a. Okay, so if you notice here it says use the change of base theorem to find an approximation to 4 decimal places. So we're going to go with 4 on these problems. Okay, now again, before I go on, I want to make sure I understand what it is I'm looking for. So when I look at the log base 5 of 17, this is asking me 5 raised to what power is going to give me 17. Well, I know that 5 to the first is 5. I know 5 squared is 25. So my answer should be somewhere between 1 and 2, because 17 is somewhere between 5 and 25, right? Okay, so the whole point of doing the change of base theorem is we can use the bases that we have on our calculator, okay? So the bases that we have on our calculator are either the log button or the ln. Which one do we use? It doesn't matter, we just have to be consistent. So what I mean by that is I'm going to change this problem here to the log base 10 of, let's see, x, and x in this case is 17, divided by the log base 10 of 5, okay? So remember, I'm writing the number 10 here, but if I didn't write the number 10, it would be understood that that's the base that I'm using, because that's what we call the common logarithm, okay? Now I'm going to do this on my calculator. So let me get my calculator. I'm going to hit log of 17, okay, close off my parentheses, divided by the log of 5, close off my parentheses, and I'm going to go to 4 decimal places. So I'm coming up with 1.7604. 1.7604. This is approximated. That's why I'm using the little squiggly kind of equals. Okay? And like I said, we can use either the log, or if we wanted to, we could have done ln, okay, which is just a natural logarithm. So I'm going to show you what I mean by that. I'm going to go ln, I'm going to type in exactly what I have. 17, close it off, divided by ln of 5, close it off, hit equals, and if you notice, I'm coming up with the exact same thing. Okay, so the whole point of using the change of base theorem is so that we can either use the common logarithm or the natural logarithm, because those are the ones that our calculators allow us to use, okay? So let's do the same thing here for this next problem, okay? I'm just going to go log, oops, I want to use your highlighter. I'm just going to go log, okay? So, excuse me, so the log of 0.1, excuse me, divided by the log of 2. So let me clear this out. Let's hit the log of 0.1 divided by the log of 2. So guys, when I'm saying that I have to, it doesn't matter which one I use, it doesn't, but I have to be consistent. So if I use log on the top, I got to use log on the bottom. If I use ln on the top, I got to use ln on the bottom. Okay, I can't mix and match. Let's see, and I'm coming up with a negative 3.3219. So we're coming up with negative 3.3219. And again, I want to emphasize that this is an approximation, so let me do this. There's our approximation, okay? And that was section 4.4, short and sweet.